Hey, what's up guys, welcome back to this video. In this video we're going to solve this coding interview question, Pascal's triangle. Given an integer numbers, return the first numbers of Pascal's triangle. This is a Pascal's triangle. This is an example of Pascal's triangle. Here we have numbers equals to 5 because here we have first 5 rows. For Pascal's triangle, value on the left edges and right edges are 1, and value here is generated by adding the value from the top. So 1 plus 1 is 2, here 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So we're getting the value by adding the 2 element on the top from previous row. This is called Pascal's triangle. If you're given numbers equals to 5, we have to return this Pascal's triangle of rows 5. Before start solving this problem, let's see some examples. For example, if you're given numbers equals to 3, then you have to return this Pascal's triangles. The Pascal's triangle represents an array of array, or you can consider a list of list. Value on the left edges and the value on the right edges are 1. And the value is generated by adding the top 2 element from the previous row. So 1 plus 1 is 2. If we are given numbers equals to 5, then we have to return this Pascal's triangles. Value on the left edge is 1, value on the right edge is 1. The value here we're generating by adding the value on the top. That means the value on the previous row. Here 1 and 1 is 2. Here 3 is summation of 1 and 2. Here 3 is summation of 2 and 1. And here 4 is summation of 1 and 3. Here 6 by adding 3 and 3. Here we generated 4 by adding 3 and 1. If you're given numbers equals to 6, then we have to return this Pascal's triangles. For first 2 row, we have 1 and 1, 1. And all the value on the left edges and right edges are 1. And value is generated from here by adding the value on the top. Here the value is generated by adding the top 2 element of previous row of Pascal's triangle. Here 3 is the sum of 1 and 2. Here 3 is the sum of 2 and 1. Here 4 is the sum of 1 and 3. 6 is the sum of 3 and 3. 4 is the sum of 3 and 1. And here 5 is the sum of 4 and 1. Here 10 is the sum of 4 and 6. Here 10 is the sum of 4 and 6. And 5 is the sum of 1 and 4. So if we're given numbers equals to 6, then we have to return this Pascal triangles. Now how we can solve this problem? For sake of understanding, let's assume we're given numbers equals to 3. First thing, what we're going to do, we're going to create a list, and in the list we're going to insert 1 for numbers equals to 1. Okay, then for numbers equals to 2, we're going to insert 1 and 1. Then what we're going to do here, the first value is 1 and the last value is 1. Now we have to generate the value on the middle. How we can generate the value on the middle? For that we have to go to the previous row and you have to add the 2 value on the top of this element here. Okay, so on the top of this element we have 1 and 1. So we will insert here 2. 1 plus 1 is 2. Don't worry about this list at index 0 and the list at index 1. Let me write out the index here. So the index of this list is 0, the index of this list is 1, and the index of this list is 2. Now how to find out this value here? Okay, so we'll insert 1 as the first value and 1 as the last value in this row. We'll see how to generate this 2 list at index 0 and index 1. Don't worry about it. We'll see how we'll do this. And here when we are generating this list at index 2, first we will insert 1. Then what we will do, we will go to the previous row. This is our previous row. Here we will add the value at index j minus 1 and j. If we consider the index of this element is j, if we consider the index of this element is j, then what we will do, we will find out the previous row. Then we're going to find out 2 value in the previous row at index j minus 1 and at index z. Here we see the index of this element 2 is 1. So we have to add the value from this list at index 0 and at index 1. First, let's find out the previous row. So previous row p for previous row equals to, let's say this is our Pascal triangle, so t. So first what we will do here, I minus 1, okay? I minus 1. If we consider the index of this row is I, then we can find out the previous row by using this formula 3i minus 1. So we'll get this list. Then how to generate this value here? We'll iterate this inner list from 1 to index I minus 1. So we'll iterate this inner list from index 1 to index I minus 1. If we consider j is the index of inner list, then we have j from 1 to I minus 1. So here we have 1 and I minus 1 is 1. So we have to iterate this inner list just once for this row index 2. So here what we will do, we'll first find out the previous row using this formula triangle I minus 1. If the index of this list is I, then we have to find out the value at this index. How we can find out this value? For that, we will go to our previous row. We have this previous row p equals to ti minus 1. Here what we will do, here we will subtract 1 from the index j. If we consider the index of this element is j, then we're going to add the value on the top of this element by this formula p j minus 1 and p j. For this element 2, at index 0 we have 1 for our previous row. So we will have here 1 plus 1 is 2. So here we will have 2. Since we have to generate the 3 rows, so we will return this list. And this is the triangles that what we have to return. Here we have 3 rows, 1, 2, 3. This is how we can solve this problem. For a better understanding, let's take another example. Let's say we're given numbers equals to 5. First thing, what we're going to do, we're going to generate a list with value 1. Then we will generate a list with value 1 and 1. We will see how to generate this value when we will go through pseudocode. So here we have the index number. Let's write here index number 0 and here 1. Now we have to generate the row at this index 2. So first what we have to do, we have to find the previous row. How to find the previous row? We will find the previous row using p equals to here. Let's say previous row equals to p. So p equals to, if you consider this is our triangle 3, then we have to use here the formula I minus 1. So we can find the previous rows using this formula ti minus 1. If we consider the index of the list is I, then here we have this list. We have to fill up this list. So how do we fill up this list? As first element, we're going to insert here 1, and then here what we have to do, we have to add the element on the top. So the element on the top is 1 and 1. How we can find out this element on the top? If we consider the index of this, if the index of this element is j, here first what we will do, we'll find out the previous row. This is the previous row, and what we will do to add the 2 element on the top of our current element here. Here we will use j minus 1, p j minus 1 plus p j. Okay, so we'll use this formula to generate the value here. So if we consider the index of this element is j, then we can use this formula. So we see the index here is 1. On the previous 2 row, on the top we have 2 value at index 0, at index j minus 1 and at index 1. So we'll add this 2 value, we'll get 2. So let's add here 2. Then at the end here of this list, we'll insert 1. Now how we will insert here 1 and here 1, we'll see that when we'll go through pseudocode. Don't worry for now. As first element, we're going to insert 1, and as last element, we're going to insert 1. We're going to run a loop here from index 1 to I minus 1. From index 1 to I minus 1. And here this value for j. And for outer loop, we will have I from index 1 to the num rows. If we consider num rows equals to n, so the outer loop will iterate from 1 to n minus 1. So we have to generate this row, then we have to generate this row. As first element and as last element, we're going to insert 1, and in the middle we will find out element in the middle of 1 and 1. We have to go to the previous row and we have to add the element on the top at index z minus 1 and at index z. Now let's generate this index 3 here. So first what we will do, we'll insert 1 as the first element. Then here we will go to the top. On the top we have 1 and 2, so we'll add here 3. Then on the top we have the 2 element 2 and 1, so we'll add here 3 using this formula z minus 1 plus p of z. Here p is the previous row, that means this row. And then at the end we're going to insert the element 1. Then at index 4, what we'll do, as first element we're going to insert here 1. Then on the top we have 3 and 1, so we're going to add here 4. Then on the top we have 3 and 3 is 6, so let's add here 6. On the top we have 3 and 1, so let's add here 4. Then at the end we're going to insert here 1. So we have here 5 rows. So numbers equals to 5. For numbers equals to 5, we have to return these Pascal's triangles. Here we are finding out the value on the middle of 1 and 1 here. So let's see how here we're calculating the value. Here we have 4. Index number is 1 of 4 here. Here we have to generate this value 4. For that, first we have to find out the previous row. On the previous row we will apply this formula. So 1 minus 1 is 0. So this element 1 and 1. So 3, 1 and 3. Then for 6, the index is 2. So 2 minus 1 is 1 and 2. So 3 and 3. Then 3 and 1. At the end we have to insert here 1. We're iterating from 1 to I minus 1. So here we have 4. So we'll iterate from 1 to 3. So here we're iterating from index 1 to 3. 1, 2, 3. And here at the first we're going to insert 1. When you're done with this inner loop, we'll insert here 1. So here we'll insert 1 and here we'll insert 1. So here we have no iteration for 1 to I minus 1 for I equals to 1. At first we inserted 1 and then at the end we inserted 1 here. And then for here we have 1, then 1 inside here we have 1 iteration of this loop. So it will calculate 2. And here we'll have 2 iteration of this inner loop. So we will calculate this 2 value. And here we'll have 3 iterations for this inner loop. So we'll calculate these 3 elements. This is how we can solve this problem. The solution will take big of n squared time complexity. Here n is the given number, that means numbers. And the solution also takes big of n squared space complexity to construct our Pascal's triangles. This is the intuition to this problem. This is how we can solve this problem. Hope you have understood how to solve this problem. Now let me show you the pseudocode to solve this problem. This is the pseudocode to solve this problem. We have this function generate. This function takes numbers as input. Then here we're creating Pascal's triangle. That means list of list. Then we have here if condition, if numbers equals to 0, then we're returning the empty Pascal triangles. If not, we're going to insert empty list and we're going to insert 1 to the empty list here. So if we have numbers equals to 4, let's see how it works. First, what we'll do here, we will insert 1 at index 0. So let's insert here 1 at this index 0. So we inserted a list and we inserted 1 in the list. Then we're running a loop from 1 to numbers minus 1. This is the index number, so that's why we're subtracting here 1. Then we're creating our current row and we have to keep track our previous row. This is our previous row. Now here we have inserted 1 to our current row, so we inserted 1 to our current row as the first element. We inserted 1. Then we're going to generate the value inside here. So we see that in this loop from 1 to I minus 1, that means from 1 to for the first iteration of this loop the value of I is 1, so 1 minus 1 is 0. So this loop will not iterate for the first iteration of this outer loop, so we'll have no element inside here. At the end we're inserting here current row and we're going to add the current row to our triangles here. Okay, so we have inserted this current row. Now let's generate the row for index 2. So for second iteration of this loop here I equals to 2. Now we're going to create a current row and we have to keep track our previous row using I-1. So this is our previous row. And here for j from 1 to I-1, that means from 1 to 1. So this loop will iterate once. So inside here first we have inserted 1 by this statement, current row dot add 1. And then here we have to generate the value at this index 2 here for this inner loop, okay? So we will find out the value at index j-1 and the value at index j. So here we will get 2 and here at the end we'll insert 1 right over here. So we generated this row at index 2. Now what we will do, we will generate the row at index 3. Here we're going to create a new list and we're going to insert 1 here, okay? This is our current row and this is our previous row. For the first iteration of this inner loop, we will add the value for this previous row at index j and at index j-1 if we consider the index of this element is j. So 1 and 2 is 3, so let's insert here 3. Here for index 2, we'll add this 2 value, 2 and 1 at index 1 and at index 2. So let's add here, so we get here 3, and at the end of this for loop we'll insert here 1 and we'll add this list to these triangles. When you have I equals to 4, we're done with this for loop. So we have generated the Pascal's triangles for numbers 4. This is how we can solve this problem. The solution takes big of n square time complexity and big of n square space complexity, where n is the given number. Hope you have understood how to solve this problem. If you have any question, if you have any suggestion, let us know. Thanks for watching this video.